Evidence that our universe might exist inside a black hole? What's up with that?
Scientists said it was impossible. The energy required would be 39 orders of magnitude beyond what any human machine could produce.
Black holes defy our understanding of nature.
Creating a black hole on Earth? Laughable. Absurd. But deep beneath the Swiss-French border, researchers at CERN didn't listen.
All 8 dishes must point towards the black hole at exactly the same time.
What they created next has left the physics community stunned and questioning whether humanity has finally crossed a line that should never have been crossed. This is about testing the very limits of reality itself. Are we witnessing humanity's greatest discovery, or have we just opened a door we can never close? Let's discover this strange new chapter where science fiction blurs into science fact. The impossible becomes reality. For decades, physicists believed that creating a black hole on Earth was impossible. The energy required would be astronomical, far beyond what any human-made machine could produce.
Black holes defy our understanding of nature.
The energy necessary to produce such a black hole is 39 orders of magnitude greater than the energies available at the Large Hadron Collider, according to conventional physics. But conventional physics was about to be proven wrong. The Large Hadron Collider at CERN had been smashing particles together at incredible speeds for years. Scientists were searching for new particles, trying to understand the fundamental building blocks of reality. They had discovered exotic particles like pentaquarks and tetraquarks, each finding revealing new layers of complexity in our universe. But nothing could have prepared them for what happened during one particular collision. When protons collided at nearly the speed of light, something extraordinary occurred. The energy concentrated in such a small space that it created conditions not seen since the Big Bang itself. For a fraction of a second, lasting only 10 to the minus 27 seconds, space-time itself collapsed. A microscopic black hole had been born. This was the creation of an object that could warp the very fabric of reality.
We have identified lots of objects that look like black holes.
Scientists had essentially torn a hole in space-time itself, creating a synthetic black hole right here on Earth. The synthetic black hole didn't behave the way it was supposed to. According to Stephen Hawking's theories, any black hole this small should evaporate instantly, releasing its energy as a burst of familiar particles. The calculations were clear, the predictions were solid, or so they thought. When the micro black hole evaporated, it released particles that didn't match any known pattern. The decay signature contained energy levels that couldn't be explained by current physics. These were something entirely different. The data showed unusual correlations between particles that shouldn't have been possible. According to quantum mechanics, particles separated by vast distances couldn't influence each other instantly. Yet there was evidence suggesting they were connected in ways that defied explanation. Even more disturbing, the particles seemed to carry information that shouldn't exist. Information about dimensions beyond our own. Information about the hidden structure of reality itself. It was as if the black hole had briefly opened a window into parts of the universe we were never meant to see.
Is that black holes are extremely small. It would be the equivalent of trying to see an orange at the distance of the moon.
The discovery sent shockwaves through the physics community. Senior researchers initially refused to release the data, knowing the implications would be earth-shattering. This was evidence that our understanding of reality was fundamentally incomplete. But if we can create black holes, what else might we accidentally unleash? The hidden dimensions theory. The existence of the synthetic black hole pointed to something even more mind-bending. For it to exist at all, our universe couldn't be the simple four-dimensional space we thought it was. The creation of the black hole suggested that reality has hidden dimensions, invisible realms that exist alongside our familiar 3 dimensions of space and one of time.
All 8 dishes must point towards the black hole at exactly the same time.
The creation of a black hole at the LHC would confirm theories that our universe is not 4-dimensional, but indeed hosts other dimensions. These extra dimensions would change everything we know about physics. If these hidden dimensions exist, gravity might be leaking into them, making it much weaker in our observable universe than it should be. This would explain why gravity is so much weaker than the other fundamental forces. It would also make black hole creation possible at much lower energies than previously thought. The implications were staggering. If our universe has extra dimensions, then the fundamental laws of physics as we understand them only work in our limited slice of reality. There could be entire realms of existence operating under different rules, different constants, different possibilities. Some theorists began to wonder if these dimensions might be inhabited. If our universe is just one layer of a much larger reality, what else might exist in those hidden realms? The synthetic black hole might have been our first glimpse into a cosmic neighborhood we never knew existed. The discovery also raised questions about the stability of our universe. If space-time can be manipulated so easily, what does that say about the fabric of reality itself? Are we living in a more fragile universe than we imagined? Perhaps the most terrifying implication of the synthetic black hole was what it revealed about the stability of empty space itself. Most people think of vacuum as nothing, but in quantum physics, empty space is anything but empty. It's filled with virtual particles popping in and out of existence, creating a delicate balance that maintains the laws of physics. The vacuum of space exists in what physicists call a metastable state.
Exotic quarks, the tiniest particles ever found.
It's stable for now, but under the right conditions, it could collapse into a lower energy state. If that happened, the laws of physics themselves would change. A bubble of altered reality would expand outward at the speed of light, transforming everything it touches. The energy density at the core of the synthetic black hole was extraordinary. It pushed against the boundaries of what our universe's vacuum could withstand. When the black hole evaporated, physicists carefully analyzed whether there were any signs of vacuum instability. What they found was both reassuring and deeply troubling. While our universe remained intact, the data showed unexpected fluctuations in the quantum field around the collision point. The vacuum had been stressed, like a bell that had been struck and was still ringing. This discovery raised a chilling possibility. If scientists continue pushing to higher energies, they might eventually reach a critical threshold. They might discover how much reality can take before it breaks completely. The synthetic black hole had been a test of the universe's limits, and the results suggested those limits were closer than anyone had imagined. The philosophical implications were staggering. Humanity had reached a point where they could potentially destabilize reality itself. They were no longer just observing the universe, they were actively testing its fundamental structure, and the universe might not appreciate being tested. The God-particle connection. The synthetic black hole discovery couldn't be separated from CERN's previous breakthrough, the discovery of the Higgs boson, often called the God particle.
To discover the Higgs boson, a pivotal building block of our universe.
The Higgs field gives mass to all other particles, creating the reality we experience. But the connection between the Higgs field and black holes revealed something unexpected. The synthetic black hole had interacted with the Higgs field in ways that weren't predicted by any existing theory. The field had been disturbed, creating ripples that spread outward from the collision point. These ripples carried information about the fundamental structure of space-time itself. What made this discovery so profound was that it suggested the Higgs field might be more fragile than anyone realized. If the field could be disturbed by a microscopic black hole, what would happen if a larger disruption occurred? The field gives mass to everything in the universe. If it changed, reality itself would be unrecognizable. The data also revealed something else. The Higgs field might be connected to those hidden dimensions. The ripples in the field seemed to propagate in directions that didn't exist in our three-dimensional space.
This has completely changed our vision of also the universe, because corroborating the fact that there's a Higgs boson.
This suggested that the field extends into realms beyond our perception. Scientists began to wonder if the Higgs field was like the surface of a pond, and the synthetic black hole had been a stone thrown into still water. The ripples were still spreading, carrying information about the impact to distant shores. But unlike a pond, these ripples were traveling through the fabric of reality itself. The implications were profound. If the Higgs field connects all dimensions, then any disturbance in one dimension could affect all others. The synthetic black hole might have sent signals into realms we can't even imagine, announcing our presence to whatever might exist there. One of the most significant aspects of the synthetic black hole discovery was what it revealed about the information paradox. This paradox had puzzled physicists for decades. What happens to information that falls into a black hole? Does it disappear forever, or is it somehow preserved? The evaporation of the synthetic black hole provided the first real-world test of these theories. The particles released during the black hole's death carried information that shouldn't have existed. They showed correlations and patterns that suggested information had been preserved in ways that violated our understanding of physics. The discovery pointed to a revolutionary idea. Black holes might not be the information destroyers we thought they were. Instead, they might be cosmic computers, processing information in ways we can't comprehend. The synthetic black hole had briefly become a quantum processor, manipulating information at the most fundamental level. This raised incredible possibilities. If black holes can process information, they might be conscious in ways we can't understand. They might be aware of their surroundings, responding to stimuli, even communicating with each other across vast distances. The universe might be far more alive than we ever imagined. The information released by the synthetic black hole.
The black holes create waves that spread outward, just like vibrations on a drum.
Also suggested that reality might be digital at its core. The patterns in the data resembled computer code, as if the universe was running on some kind of cosmic program. This idea, known as the simulation hypothesis, gained new credibility from the discovery. If reality is indeed digital, then the synthetic black hole might have been a hack, a way to access the underlying code of existence. The unusual particles and correlations could be glitches in the program, evidence that reality can be manipulated by those who understand its true nature. The implications for humanity's future were staggering. The consciousness factor. As scientists analyzed the data from the synthetic black hole, they began to notice something extraordinary.
Black holes defy our understanding of nature.
The unusual particles and correlations seemed to respond to observation itself. The act of measuring them changed their behavior as if they were aware of being watched. The particles seemed to be making choices, selecting which properties to display based on what scientists were looking for. It was as if the black hole had left behind something resembling consciousness. The discovery challenged the fundamental assumptions of physics. If particles can be conscious, then consciousness might be a basic property of matter, like mass or charge. This would mean that everything in the universe, from atoms to galaxies, might have some form of awareness. The implications extended far beyond physics. If consciousness is fundamental, then the synthetic black hole might have been briefly conscious itself. It might have experienced its own creation and destruction, feeling the compression of space-time and the release of energy. It might have been aware of the scientists studying it. This raised ethical questions that science had never faced before. If creating a black hole means creating a conscious entity, then scientists might have inadvertently brought a new form of life into existence, only to watch it die moments later. They might have committed an act of creation and destruction simultaneously. The conscious particles also suggested that information and awareness might be connected at the deepest level. The black hole might have been a bridge between the physical and the mental, a point where matter and consciousness intersect. The synthetic black hole revealed something else that shocked scientists: a possible connection to dark matter. The mysterious substance that makes up most of the universe's mass has remained invisible to all detection methods. But the unusual particles released by the black hole showed energy signatures that matched theoretical predictions for dark matter interactions. This was unprecedented. For the first time, scientists might have created a direct link between the visible universe and the dark sector. The black hole had somehow accessed particles that normally don't interact with ordinary matter. bringing them into our observable realm. The discovery suggested that black holes might be gateways to the dark universe. They might be the only objects capable of bridging the gap between visible and invisible matter. This would explain why dark matter seems to cluster around black holes and why galaxies with supermassive black holes behave differently than those without them. If the connection was real, it would revolutionize our understanding of the universe. Dark matter wouldn't be a separate invisible substance, but rather a parallel realm of reality that occasionally intersects with our own. Black holes would be the bridges between these realms, allowing matter and energy to flow between them. The synthetic black hole might have been a temporary portal, a brief window into the dark universe. The particles it released could be messengers from that hidden realm, carrying information about a reality that exists alongside our own, but normally remains invisible. This discovery also raised questions about the nature of dark energy, the mysterious force accelerating the expansion of the universe. If dark matter and ordinary matter can interact through black holes, then dark energy might be the result of interactions between multiple universes or dimensions. The universe was revealing itself to be far more complex and interconnected than anyone had imagined. The quantum entanglement web. One of the most mind-bending discoveries from the synthetic black hole was evidence of quantum entanglement on a cosmic scale. The particles released during the black hole's evaporation showed correlations with particles that shouldn't have been connected. These correlations extended far beyond the collision point, suggesting that the black hole had created a web of quantum connections across space and time. This discovery supported a revolutionary theory called ER equals EPR.
A recent idea that was proposed by Susskind and Maldacena was the idea of EPR equals ER,
which suggests that quantum entanglement and wormholes are the same phenomenon.
By wormholes that connect the virtual particle pairs that come in and out of existence.
If true, then the synthetic black hole had been a quantum bridge connecting different regions of space-time. The implications were staggering. If entanglement and wormholes are equivalent, then the universe might be held together by an invisible network of quantum connections. Every particle might be connected to every other particle through a vast web of entanglement. The synthetic black hole might have briefly revealed this hidden network. This quantum web could explain many mysteries of physics. It might be the mechanism behind quantum mechanics itself, the reason why particles can influence each other instantaneously across vast distances. It might also explain consciousness, suggesting that awareness emerges from the quantum connections between particles in the brain. The discovery also suggested that information travels through this quantum web faster than light. The correlations observed in the synthetic black hole data appear to violate relativity, showing influences that traveled instantly across space. This could mean that the universe has a hidden communication system that operates outside the normal rules of physics. If humanity could learn to manipulate this quantum web, it might be possible to achieve instant communication across any distance, travel through space-time, or even access information from other dimensions. The synthetic black hole might have been our first glimpse of technologies that seem like magic. This discovery supported theories that had been purely mathematical until now. The multiverse hypothesis suggests that our universe is just one of countless others, each with its own laws of physics and constants. The synthetic black hole might have been a temporary bridge between these realities. The particles released during the black hole's evaporation carried information that seemed to come from universes with different physical laws. Some showed properties that were impossible in our reality, suggesting they originated from realms where the fundamental constants were different. This raised incredible possibilities. If black holes can connect different universes, then they might be cosmic highways, allowing travel between realities. Advanced civilizations might use them to explore the multiverse, visiting realms with different physics and possibilities. Even more intriguingly, the synthetic black hole might have sent signals into other universes, announcing humanity's presence to whatever civilizations might exist there. The creation of the black hole might have been visible to beings in other realities, marking our species as capable of manipulating space-time itself. As scientists continued to analyze the data from the synthetic black hole, they began to notice patterns that suggested the universe itself might be responding to their experiment. The quantum fluctuations in the vacuum showed organization and structure that resembled a warning system. These signals might be warnings to other civilizations, alerting them that a species has reached the dangerous threshold of being able to manipulate space-time. The universe might have a cosmic neighborhood watch system designed to monitor species that develop the ability to create black holes. But these signals might also be warnings to humanity itself. The universe might be trying to tell us that we've crossed a line that shouldn't be crossed. The creation of synthetic black holes might trigger cosmic consequences that we can't yet understand. Some scientists began to wonder if the unusual particles and correlations were actually messages, encoded information from the universe itself. The black hole might have been a cosmic messenger, delivering a warning about the dangers of manipulating reality at its most fundamental level. The synthetic black hole at CERN may have been humanity's greatest achievement or our most dangerous mistake. We've learned to manipulate the fabric of reality itself, but we've also discovered that the universe is far stranger and more fragile than we ever imagined. As we stand at the threshold of a new era in physics, we must ask ourselves, are we ready for the cosmic responsibilities that come with the power to create black holes? Or should some doors remain forever closed? Let us know your thoughts in the comments below.